Hello dear students of class 7, this is Priyanka Upadhyay, your physics teacher, and today in this video we are going to learn a second chapter, that is force and pressure. Okay, so in the previous class we have studied about the effects of force. So we will just recall them. The effects of forces are: force can change the speed of a moving object. Okay, so if you are applying force in the same direction where the object is moving, the speed of the object will increase. But if you apply force in the opposite direction of the motion of the object, the speed of the object will reduce. Second one, force can change the state of motion. Force can stop moving object. Force can change the direction of moving object. Force can change the shape and size of object. So basically force is a cause which either changes the shape or size of the object, or it changes, or it is responsible for the change of state of rest or of motion. So this is about force. So our next thing is rest and motion. So we will study about rest and motion. See here, everything in the world is at rest or in motion. You can see things around you. Most of the things are at rest and some of the things are at motion. Okay, so there is no meaning of rest and motion without the viewer. If we are not there, if viewers are not there, so then there is no meaning of rest and motion. So now we will study what is rest. See here, if a body is not changing its position with respect to its surrounding and with respect to time, the body is said to be at rest. See here, a body is said to be at rest if it does not change its position with respect to its surroundings. For example, wall. For examples, your cupboard. For example, your, it may be any of the things. Okay, so your home. A body is said to be at rest if it does not change its position with respect to its surrounding. So some of the things around you are not changing their positions with respect to surrounding or with respect to time. So examples are, see, a tree is at rest because it is not making any motion, any movement. A building is at rest, walls are at rest. Okay, so some more examples. A passenger sitting in a moving bus are said to be at rest with respect to driver of the same bus. Here, when you are traveling in a bus or train, what happens, or in a vehicle, you will be at rest, okay, with respect to the surrounding. Okay, so next thing is motion. So what is motion? A body is said to be in motion if it changes its position with respect to its surrounding. So if a body is changing its position with respect to time and surrounding, then the body is said to be in motion. For example, vehicles around you are moving, people around you are moving. Okay, so leaves of the trees are moving, so they are said to be at motion. So next one is relative rest and motion. So these rest and motion are relative terms. So how they are relative? See here, when you are sitting in a train and you are traveling, okay, with respect to a person who is sitting beside you, you are at rest. But with respect to a person who is standing on the platform, you are moving. So it means you can relate rest and motion. Without relating rest and motion, you cannot say whether the object is at rest or the object is at motion. So next is scalar and vector quantities. See here, physical quantity which has only magnitude is known as scalar quantity. For example, we have studied about many physical quantities in our previous class, that is time, length, mass, temperature. These all are physical quantities, and even we have studied about force, displacement, velocity. So these are also physical quantities. But some of the physical quantities have only magnitude. For example, mass. When you express mass, it will be 5 kg, 2 kg, 500 gram. So there is no specified direction for some of the physical quantities. So such physical quantities which are having only magnitude are known as scalar quantities. Okay. For example, mass, length, time, volume, and distance. So next one is vector quantities. See here some of the physical quantities which have both magnitude and direction. So such physical quantities are known as vector quantities. For example, velocity, displacement, force. If you take force, force always acts towards the center of gravity. So it means it is giving you some particular direction. Velocity gives you particular direction along with the value, along with the magnitude. Displacement gives you the particular direction along with the magnitude. For example, if a force acting on a body is 2 kgf, it will act towards the center of the earth. Okay, so here 2 kgf is the magnitude and the direction. It is acting towards the center of the earth. It is the direction. So physical quantities which have both magnitude and direction are known as vector quantities. So our next thing is distance. Okay, so distance is the actual length or actual path covered by the body. For example, here you can see in this picture, the boy, a man is traveling from this point to this point. Again, he travels from this point to this point. Okay, so the distance traveled by him is 7 kilometers here. He has started from here and again he is moving. So here he has stopped. So what is the distance traveled by him? It is the total path. So we are just adding the total path 5 plus 2. So the total path is how much? 7 kilometer. Next, in the second picture, see here, man is traveling from this point to this point. Okay, so he is traveling from here to here and again he is coming back. So the distance between these 2 points is how much? 5 kilometer. So therefore the total distance traveled by him is 10 kilometer. He is going from point A to here to here. That distance is 5 kilometer. Again from here to here, that distance is 5 kilometer. So the total distance, total path covered is how much? 5 plus 5 while going and while coming. So this is 10 kilometer. So remember, distance is a scalar quantity. It doesn't have any direction. It has only magnitude. For example, 5 kilometer, 7 kilometer, 2 kilometer, 10 kilometer and 3 kilometer, 500 meters. So these are the things how we express distance. Okay, so next one is displacement. So displacement of the body, here you can see here, displacement of the body is the shortest distance between the initial and final position. For example, in this picture, man has started from here and he goes to this position and again he goes to this position. So here in this picture, what happens? The total distance traveled by a man is 5 plus 2 kilometer. But the total displacement by the man is found from initial position to final position. From initial position to final position, we will take the shortest distance. We will take the shortest line and that gives us the displacement. Okay, if it is 5 kilometer and if it is 2 kilometer, so by calculation, we will get that displacement is how much? 6.57 kilometer. But the distance is how much? It is 7 kilometer. Okay, so here in this case, in the second picture, you can see the boy again he is starting from one position and again he is reaching another position. So the distance between two positions is 5 kilometer. But again from this position he is coming back to the initial position. So here what the definition of displacement says: displacement of a body is the shortest distance between initial and final position. So what is his initial position? Initial position is this one, and again the final position is this one. So what is the displacement by him? Definitely it would be 0. Okay, displacement by him would be 0, because we are calculating displacement from the initial position. So again he comes back to the initial position, therefore displacement will become 0. So displacement can be 0, displacement can be positive, or displacement can be negative. Okay, but distance is always positive and distance can never be 0. So some of the conclusions, see here we have point A and point B. This is point B. Okay, so this ball has traveled through this path. So this is the distance. This dotted lines indicates the distance traveled by the ball. But the shortest distance between the initial and final position of the ball gives us the displacement. Okay, so some of the conclusions about displacements are here. Displacement is vector quantity. See, displacement is a vector quantity because it has magnitude and also it has direction. Displacement has units of length. See, distance is measured in terms of meter and displacement is also measured in terms of meter. So displacement also has the units of length. Third one, the displacement of an object in a given time interval can be positive, 0 or negative. As I have said earlier, displacement can be positive, negative, or it may be 0. See, the actual distance traveled by an object in a given time interval can be equal to or greater than the magnitude of displacement. So what does it mean? Here in this case you can see that maybe the displacement may be 4 kilometer and the distance is how much? It is only 3 kilometer. So it means displacement is always equal to or less than the distance. It can never be greater than the distance. Next, fifth one, the displacement of an object between 2 points does not tell exactly how the object actually moved between those points. Okay, sixth one, the displacement of a particle between 2 points is unique path which can take up the particle from its initial position to final position. Displacement is always from initial position to final position. Here, last one, the displacement of an object is not affected due to shift in the origin of the position axis. So if you shift the origin of the uh, position axis, the displacement is not going to change. Leave the 7 point, it is not there in the syllabus. Okay, leave. Next one is speed. Okay, so what is speed? As we have learned, speed is defined as the time rate of change of distance of a body, or it may be defined as, or it is defined as the distance traveled by the body in unit time. So how we write? Speed is equal to distance divided by time taken. Okay, if a body travels through a distance s in time t, then its speed v is given by s divided by t, that is distance traveled divided by time. Speed is a scalar quantity. Speed is either positive or 0, but it never be negative. We can see that. See, some of the vehicles, we can say the speed of the vehicle is 0. It means it is not moving. But see, the speed can never be negative. Speed is always either it is positive or it is 0. Speed of a running car is measured by speedometer. Okay, speed is measured in CGS system. The speed is measured in centimeters per second. But in SI system, the speed is measured in meter per Second, see, in practice life, when distance and time are large, for example, when we are moving from one state to another state, at that time, we will use the higher units, that is kilometer per hour. Okay, this is about speed, and there is one more quantity, that is velocity. See, speed is a scalar quantity. Distance divided by time, distance per unit time gives us speed, and displacement per unit time gives us velocity. So therefore velocity is a vector quantity. So next one is average speed. The average speed of a body is ratio of total distance traveled to the total time taken to cover the distance. For example, average speed is defined as total distance traveled divided by total time taken. For example, you are moving from Pune to Mumbai. The distance between Pune and Mumbai is 150 kilometer, and while going you took 2 hours to reach Mumbai, but while coming back you took 3 hours to reach Pune. So in this case, the total distance traveled, that is from Pune to Mumbai 150 kilometer, and Mumbai to Pune 150 kilometer. Total distance traveled is how much? 300 kilometer. And total time taken is how much? While going it was 2 hours, and while coming back it was 3 hours. So it means 2 plus 3, 5 hours. So total distance is 300 kilometer divided by 5 hours. So it is going to give you the average speed. Next one is uniform speed. A body has uniform speed if it travels equal distances in equal intervals of time, no matter how small these time intervals may be. It means a body is traveling equal distances in equal intervals of time. Okay, so what does it means? See here, a body is said to have uniform speed only when it covers equal distances in equal intervals of time. It means in the first hour, if the body is covering 30 kilometer, in the next hour it also the body covers 30 kilometer itself, and in the next hour also the body covers 30 kilometer per hour. So this is uniform speed. Okay, so here you can see here, this is first hour. In the first hour, the body is covering X distance. Again, in the second hour, the body covers X distance. Again, in the third hour, the body covers X distance. Again, in the fourth hour, the body covers X distance. So this is about uniform speed. And next one is uniform motion. See, a body has uniform motion if it travels equal distance in equal intervals of time, no matter how small these time intervals may be. Again, same. Uniform motion and uniform speed are also same. Okay, so last one is non-uniform motion. If a body is traveling unequal distances in equal intervals of time, for example, in the first hour the body covers 30 kilometer, and in the next hour if the body covers 40 kilometer, and in the very next hour if the body is covering 50 kilometer, then the motion is said to be non-uniform motion. You need not take these all things in kilometer and hour. You can consider those in meters and second also. So I'll give one example. In the first hour, if the body is covering 2 meter per second, okay, in 1 second, in the first second, if the body is covering 2 meters, and in the next second, if the body is covering 3 meters, and in the third second, if the body is covering 1 meter. So it is said to have non-uniform motion. Okay, next one we will study about types of motion. Different objects move differently. Some objects move in a straight line, and some move in a curved path, and some move in other different way. So there are three types of motion, mainly three types of motion. Translatory motion, second one rotatory motion, and third one vibratory motion. See here, the motion in which every point on the moving body moves through the same distance in same interval of time is called translatory motion. See here. In translational motion, what happens? A body moves along a straight line. The line may be straight or curved. Okay. The body moves in a straight line. This line may be straight or curved. For example, a car moving in a straight line is in translational motion, and a train moving along a straight line also has translational motion. Okay, second, in translational motion, again we have three types of motion. First one is linear motion. Linear, as the name states, body always moves along straight line. For example, aeroplane flying in a straight line. Second one, we have circular motion. Circular motion, okay, that is nothing but curvilinear motion. Okay, so curvilinear motion. So in this case, circular motion is nothing but curvilinear motion. So if a body moves in a circular path or a curved path, the body is said to be in curvilinear motion or circular motion. Next, third one is random motion. See, the disorder or irregular motion of an object is known as random motion. Gas particles always they follow random motion. They are not bound. Okay, they can travel. They can take their own path. So that type of motion is known as random motion. So next one is rotatory motion. When a body moves about a fixed axis without changing its position, the body is said to have rotatory motion. See here, if the body moves about a fixed axis, for example, you can consider your fan. Okay, it moves about a fixed axis. The fixed axis is the line which is at the center, that axis. Okay, so that is the fixed axis about which fan rotates. So that type of motion are known as rotatory motion. So first example, the spinning motion of a body about its axis is called rotatory motion. An axis is line around which a body rotates. So you all know about the axis. You have a steering. In car we have steering. Okay, that steering have a line. Okay, so that line is known as axis. Motion of a wheel about its axis and that of a steering wheel are the example for rotatory motion. Next one, oscillatory motion. Oscillatory motion, here, a motion in which body moves to and fro, that is back and forth, about its mean position is called oscillatory motion. Here, when you are sitting in a swing and you are making to and fro motion, that is back and forth motion, and that type of motion is known as oscillatory motion. Simple pendulum is the best example for oscillatory motion. It makes to and fro motion. Okay, next one is vibratory motion. A motion in which part of a body and move to and fro in a definite style while the rest of the body always remains fixed is called vibratory motion. See here, uh, if the swing is set, it vibrates back and forth as you swing it. And motion of a pendulum of a clock. See, you might have seen pendulum clocks. This is the pendulum of a clock. So this is fixed at one position and other part moves. It makes to and fro motion. Tuning force also vibrates. See here, take a scale, okay, and keep it on the edge of the table and just sorry, just place your hand on the scale and tap the scale. The scale will start to vibrate. It start to make to and fro motion. So one end will be fixed and another end will be making motion. So this kind of motion is known as vibratory motion. So some examples of oscillatory motions are here. So simple, first one, it is a simple pendulum. It makes to and fro motion. Second one is spring. It also oscillates, okay, above its mean position. Third one is swing. Swing is an example for oscillatory motion. Next one example for next one is periodic motion. A motion which repeats itself after regular interval of time is called periodic motion. See here, uh, if you see the needle of the clock, okay, again after 12 hours, again it comes to original position. Again after 12 hours, it comes to original position. So this type of motion which repeats itself. Is this motion repeating itself? Yes, after 12, again after 12 hours, it repeats itself. So this type of motion is known as periodic motion. A motion which repeats itself after a regular interval of time is known as periodic motion. Next one. Okay. So here all oscillatory motions are periodic motion. Here we can say that all oscillatory motion. For example, swing. You are making to and fro motion. You are going back, again coming front, going back, coming front. It means the motion is repeating itself. So such kind of motion is known as periodic motion. So all oscillatory motions are periodic motion, but all periodic motions are not oscillatory motion. See here. So this spring, it goes front, again it comes back. So this is oscillatory motion. This oscillatory motion is a periodic motion. But here the moon revolves around the earth, rotates around the earth. So this is periodic motion. Again, after 30 days, it comes to its original position. Okay, moon comes to its original position. Again, the motion is repeated. But this motion, this periodic motion is not a oscillatory motion. So it means all oscillatory motions are periodic, but all periodic motions are not oscillatory. Next one, complex or multiple motion. See here, complex or multiple motion. So what do we mean by complex and multiple motion? See, a motion in which combination of two or more types of motion is called multiple motion. See here, there should be two or more types of motion involved. When you ride bicycle, the first example, when you ride bicycle, so there is circular motion, rotatory motion in wheels. But how do you move? In a straight line, in a straight road, on a straight road, you are moving on a straight road. So that is which kind of motion? Linear motion. Linear motion plus rotatory motion. Again, here you can say that this is oscillatory motion. Again, the wheels are coming to same position. Again, they are making the motion. See here, wheels of moving vehicle. Wheels of moving vehicle. Okay. So here, wheels are in rotatory motion, but again they are moving in a straight path. So these are the combination of two or three types of motion or multiple motion. So that is known as complex or multiple motion. So next one, we will study about simple pendulum. Here, a heavy point mass is suspended by a weightless, inextensible and perfectly flexible string from a rigid support. Then this arrangement is called simple pendulum. You can see here, this is inextensible string and it is perfectly flexible. Okay, the string is perfectly flexible and the bob is weightless and it is supported to a rigid support. Such kind of arrangement is known as simple pendulum. Okay, so pendulum consists of a small metallic solid sphere suspended by a fine thread from a rigid support. This is the practical simple pendulum which is nearest to the ideal simple pendulum. Okay, it is supported through the by the silk thread. So next, definition of simple pendulum. An ideal pendulum consisting of a point mass suspended by weightless, inextensible, perfectly flexible thread and free to vibrate without friction. See, a simple pendulum. It is a heavy point mass suspended by a weightless, inextensible and perfectly flexible string from rigid support. This is known as simple pendulum. So some of the terms which are related to simple pendulum. So first one is point of suspension. Here point of suspension is a fixed point in a rigid support from which the pendulum is suspended. So here is the point of suspension. Okay, it is a fixed point. Okay, where the fixed point or rigid support from which the pendulum is suspended. Okay, this is the same pendulum, single pendulum, but we have shown the position of the pendulum in some time t. Okay, so point of oscillation. The center of gravity of the pendulum is called the point of oscillation. The center of gravity of pendulum, this point, the center of gravity of pendulum is called point of oscillation. Third one, length of the pendulum. See here, pendulum has length from rigid support till the center of gravity. So this is known as the length of pendulum. Next one, mean position or rest position. So when the pendulum is at rest, so that will be, the pendulum will be at this position. So this position of the pendulum is known as mean position. Okay, so next one is extreme position. So this A and B are extreme position. When you take a pendulum here and you leave your fingers, it moves from here to here. So these are known as extreme position. The position of the bob at maximum distance. Here, the position of the bob at the maximum distance on both the side of mean position. On both the side of mean position. Okay, up to which the pendulum can oscillate are known as extreme position. Till here the pendulums can oscillate. So this is known as extreme position. Okay, next one oscillation. See here, one complete to and fro movement of a pendulum about its mean position is known as one oscillation about its mean position. See here, when we say that one oscillation is completed, see here, the pendulum is here. So initially it goes to A, again it comes back to O, it goes to B, and again it comes back to O. So it means one oscillation has completed. O to A to O, O to B, and again B to O. So it indicates that one oscillation has completed. Next one, amplitude. So amplitude, the maximum displacement of the pendulum from mean position is known as amplitude. See here, from mean position to A. So this much of distance, maximum displacement is known as amplitude. See here, mean position of the pendulum, and this is extreme position of the pendulum. So distance between mean position and extreme position, the maximum displacement of the pendulum is known as amplitude. Next one is time period. Okay, so what is time period? The time taken by a pendulum to complete one oscillation. So one oscillation, from where does it start? Say along with me, O to A, from mean position to extreme, again extreme to mean, again mean to another extreme position, that is B, again B to O. So it means one oscillation has completed. So whatever the time it has taken to complete one oscillation is known as time period. Whatever the time it has taken to complete one oscillation is known as time period of the pendulum. Next one is frequency. See here, what does the frequency mean? See here, number of oscillations in 1 second. In 1 second, how many oscillations are there? In 1 second, how many times the pendulum is completing the oscillations is known as the frequency. Frequency is denoted by the letter F and the unit of frequency is hertz. Okay, and time taken by the pendulum is denoted by T and it is measured in seconds. Okay, amplitude. Amplitude is nothing but displacement and it is measured in terms of meter. Okay, so this is about the terms which are related to pendulum. So next thing is force. Okay, a physical cause which changes either the size or shape or sets a body into motion or brings a body to rest is known as force. So we all have studied about the force in the previous year also. So before also we have discussed about the force. So example, if an iron nail is hammered, it changes its shape. Okay, iron nail is hammered, then what happens? It changes its shape. If a ball is pushed, it starts rolling. That is, by pushing the ball started to roll. When you push a ball, when you apply force, ball starts to roll. The driver of a vehicle applies brakes to stop his vehicle. Applying brake is nothing but applying force. Okay, then that time what happens? Vehicle stops. So units, we will study about units. The SI unit of force is Newton. Okay, and it is represented by capital N. CGS unit of force is dyne, and 1 Newton is equal to 10 raised to 5 dyne. So other units of force are kgf, kilogram force, or gf, that is gram force. Force can be applied on a body by two different ways. Here, by touching the body, that is by contact, that is push, pull, squeeze, stretch, friction. These are the contact forces. And without touching the body also, we can apply the force. Such type of forces are known as non-contact force. In that, gravitational force, magnetic force, and electrostatic force comes. So next one is weight. This physical quantity is also kind of force. In everyday life, we use the term weight instead of mass. But in physics, mass and weight have different meaning. Here, when you go and you buy something, 1 kg of something, so that is mass. Okay, every day we often confuse weight with the mass. But in physics, mass and weight are different. Here, a body has some mass in it, but a force with which the earth attracts the body is known as its weight. The body with which the earth attracts, the force with the earth attracts body is known as weight. So you have some mass in your body, okay? Earth is applying force and it is attracting you towards the earth. So that is known as weight. The SI unit of weight is Newton because weight and force are same. Okay, so SI unit of weight is Newton. Weight is also measured in kilogram force. It is the force with which 1 kilogram mass is attracted by the earth. 1 kgf means the force with which 1 kilogram mass is attracted by the earth. So you have some mass in your body and earth is attracting you. Okay, so in that case what happens? It will become weight of the body. It has been found that 1 kg of 1 kilogram force is equal to 10 Newton. The weight of a body is equal to product of mass and acceleration due to gravity. That is weight of a body. W is equal to mass and gravity. Mass with which the earth is attracting you. Mass with which the earth is, force with which the earth is attracting your body mass is known as weight. So where m is the mass of the object and g is the acceleration due to gravity. Okay, so in your textbook you can see there are two instruments to measure weight. Okay, so spring balance. The instrument commonly used to measure weight is spring balance, and I have already shown you spring balance in 6th standard. Okay, spring balance is a form of balance having helical spring. Okay, so next one is electronic balance. It's a very sensitive and accurate balance. The object to be measured is placed on a platform and the weight can be read on the screen. As this balance is very sensitive and accurate, it is used in laboratories and in jewelers and grocers shop to make accurate measurement. Electronic balance is being used. From our previous concepts, we know mass is the amount of matter contained in a body. Mass is what? It is the amount of matter contained in a body. But weight is the force with which the earth attracts a body. Okay. Mass is constant quantity for a body irrespective of its position and surrounding. Here, even mass does not change from one point to one place to another place, but weight changes. Okay, weight changes. Mass of a body can be expressed in different units like kilogram, gram, quintal, ton. But weight is measured in terms of Newton, kilogram force and gram force. So there are some differences between mass and weight that has been given in your textbook. Please go through it. So question and answers will be discussed and it will be sent through the PDF. Thank you, my dear children. Bye bye.